I should wait for a few minutes, right? And then I'll start. Mm. Hello, good afternoon, everyone. Welcome to another interview session by 360 TGTMG. I hope you can see the screen. Okay, so today we are going to prepare questions on decision tree module. So first of all, first question is, what is decision tree? Okay, so what is decision tree? So a decision tree is a tree-like structure of all the possible solutions to a decision, which are based on certain conditions. There is a target variable which can take discrete values, and the target variable which take discrete values are called as classification trees, and the target variables which take continuous values are called as regression trees. So basically, this is what decision tree is called. Second question. Why do we use decision tree? Instead of any other module, why to use decision tree? Why to use decision tree? Okay, so we use decision tree because it is easy to understand. As compared to any other modules, it is much easier to understand. There are various algorithms in machine learning programs. So choosing the best algorithm for the given data set and the problem is the main point. So always look at the given data set and the problem, and basis of that decide your module, decide your algorithm. Basically, we choose decision tree because it is easy to understand, and the logic behind the decision tree can be easily understood because it shows like a tree structure. If you guys are having doubts, you can ask in the chat window. Next question is, what are the terminologies involved in the decision tree module? What are the involved in decision tree? Okay, so basically there are four or five terminologies involved in decision tree. First, it is root node. What is the function of root node? So root node is from where the decision tree starts. Basically, what is the function of root? It is the function of decision tree also. It is where the decision tree start. It represents the entire data set, which further gets divided into two or more homogeneous sets. Depending on the data sets, it get divided. Second terminology is leaf node. Now, what is leaf node? It is the final output node, and the tree cannot be segregated further after getting a leaf node. If you get a leaf node, that means your module is complete. You have finally completed your decision tree. You cannot segregate it further. Then you have branch or subtree. What is that? A tree formed by splitting the tree. That's all. And last, you have the child node, parent or child node. The root node of the tree is called as parent node, and the other nodes are called as child nodes. There is one more terminology in decision tree, which is pruning. And when do we use pruning? When we are facing overfitting issues. So pruning is the process of removing the unwanted branch or branches from the tree. These all are the terminologies involved in the decision tree algorithm. Then next question, we have, how does the decision tree algorithm work? How does the decision tree algorithm work? Okay, so how does decision tree work? So in a decision tree, for predicting the class of a given data set, the algorithm starts from the root node. As right now I said that root node is the starting node. So to predict the class, we start with the root node. This algorithm compares the value of a root attribute with the real data set. And based on the comparison, it follow the branches and jump to the next node. And for the next node, the algorithm again compared the attribute value with other nodes and move further like this only and repeat this steps. And it continue the process until it reaches the leaf node of the tree. Because I said leaf node, wait a second. Yeah, sorry for that. Yeah, so leaf node is the last node, is the ending node. So it continues the process until it reaches the leaf node. Clear that how does the decision tree algorithm work? Now moving on to the next question. What is cart? The answer is hidden in the name itself. The cart stands for classification and regression problem. Regression trees, sorry. So a classification and a regression tree is a predictive algorithm used in machine learning, and it explains that how a target variable values can be predicted, like whether it would be discrete or whether it would be continuous. This is known as cart. So decision trees are also known as cart, classification and regression trees, because it solves both problems, classification as well as regression. Okay, so next question. How to represent decision nodes. How to represent decision nodes? That means what is the shape of representing decision nodes, like whether it is disk or circle, square or triangle or any other shape. So the shape of decision node is squares. We use squares to represent the decision nodes. Wherever there is a square, you can assume that it is decision nodes. So decision node represented by a square, which shows a decision to be made. For different nodes, there are different shapes. So you have to remember that for decision nodes, you use square. Okay. Next question. What is the maximum depth in a decision tree? What is the maximum depth in the decision tree? In a decision tree. So what is the maximum depth? Maximum depth means till where we can expand the tree. We can expand the branches of the tree. So there should be some maximum depth. So the root node is considered to have a maximum depth. I mean, like the maximum depth value cannot exceed 30 on a 32-bit machine. It depends on a machine, like 32-bit machine, or you have a 64-bit machine. So it depends on that. So overall, for a 32-bit machine, the depth value cannot exceed more than 30. So the length of the longest path from a root to a leaf. Basically, that is the maximum distance, maximum depth, what I mean. And if you go by machine configuration, it depends on your system. Clear? So your next question is, what kind of algorithm is a decision tree? What kind of algorithm? What kind of algorithm is decision tree? What kind of algorithm means whether it is supervised or unsupervised or both or none, I mean like that. So decision tree is a supervised learning, which means it predicts values of responses by learning rules derived from the features. Features means columns. So it is a supervised learning, not unsupervised or both. This could be confusing. You could get confused that whether it is unsupervised or supervised. Just clear with your thought that it is supervised learning because it predicts values of responses by learning decision rules derived from the features. Next question is, what is the drawback of decision tree? Everything has advantages as well as disadvantages. So what is the drawback of decision tree? So the disadvantages is that decision tree are less appropriate for estimation task. What do you mean by estimation task? That means where the goal is to predict the value of a continuous attribute. So here it is the drawback of using a decision tree. Drawback means it is not the strength. Okay. Decision tree are less appropriate for estimation task. Estimation task means where the goal is to predict the value of a continuous variable. Okay. Next is, what is entropy? What is entropy? So, what is entropy? Can anyone tell me in the comment chat window? Okay. So entropy is the measure of a uncertainty of a random variable. Entropy means the impurity. You cannot say directly the error, it's the impurity. It is the measure of uncertainty of a variable. It characterizes the impurity of the collection of examples or whatever values you have. It shows the impurity. Okay. Next question is, how does the decision tree reaches its decision? Wait a minute. How does the decision tree reaches its decision? How does the decision tree reaches its decision? So they reach their its decision by performing a sequence of tests. There is no single or it's not fixed the number of tests. they perform a sequence of tests. Clear? So a decision tree reaches its decision by performing a sequence of tests. Multiple tests they perform, a sequence of tests they perform to reach their decision. Okay. So how many nodes are there in a decision tree? How many nodes are there in a decision tree? वैसे तो I have tell you about all the nodes, but it's just that 4. There are 4 nodes in the decision tree. Okay. Next question. These are the easy question, but confusing one also. You might get confused while answer this question. Like 3, oh no, 4, like that. So you should be pretty clear that how many nodes and what are the nodes available in the decision tree. Next question is, are child node and branch node same in the decision tree? Yes or no? Are they same? Or they call to different values? Yes, they are the same. Both are the same. Child node and branch nodes are the same. They both refer to same value. I mean, whether you called the node as child node or whether you called it as branch nodes. Okay, then. Why do we use pruning? Why do we use pruning? Pruning is used for cutting or trimming the tree. You know, wherever you face any overfitting values, what do? You use pruning. And what do you mean by pruning? To cutting or trimming the trees. To already define the depth of the tree. Remove the branches. What does pruning do? It removes the branches of decision tree to overcome the overfitting condition of decision tree. So wherever or whenever you face the overfitting issues, always go for pruning. Decision tree learners may create, okay, next question I'm asking. Decision tree learners may create biased trees if some classes dominate. This kind of tricky questions might come into your interview. If some classes dominate, so what is the solution for this? So what is the solution for this? Anyone? What is the solution for this? Let's say if the decision tree learners may create biased tree. It is possible decision tree learners may create biased trees. Because if some classes dominate now, so they have to create biased trees. So how to solve this issue? How to not create biased trees? If we do have some dominant classes. So what do? We balance the data set prior to fitting. Before fitting the data set, we balance it. Decision tree learners create bias tree if some classes dominate. So it is therefore recommended to balance the data set prior to fitting with the decision tree. What does that mean? Before using that into the decision tree algorithm, always fit the data set. Balance the data set, I mean, before fitting. Before fitting into the model, always balance the data set to avoid this situation, to avoid creating the bias tree. Okay, remember this thing, how to solve this issue, how to solve that instead of creating bias trees, how to solve that? By just balancing the data set. Okay. So, next question, what strategies can help reduce over overfitting in decision tree? So what are the strategies which help to reduce overfitting? I also mentioned pruning. So pruning is one of the strategies which help in reducing overfitting. And there is also enforce a maximum depth for the tree. Means decision tree don't use regularization to fight against overfitting, because in other algorithm we use regularization techniques, but in decision tree regularization is not used. So instead we used pruning. We have learned that. And we also use the right hyperparameters. That means the maximum depth we can already define. Like maximum depth equals to 4 or 5. Like it would not get segregated more than 4 or 5. Whatever number you are defining for the max depth. Okay. So next question is, how do we pick the best split in decision tree? How do we pick the best split in the decision tree? How can we do that? Should we maximize the entropy or should we minimize that? We should go for minimization. Minimize entropy is the key idea to pick the best split. Always go for minimizing the entropy. This will give you the best split in the decision tree. Because this is the impure. Entropy stands for impurity. So by minimizing the impurity, definitely you will get the best split. Clear? Yeah. Next question. How to represent chance nodes? How to represent chance nodes? I mean, what is the shape you use while representing the chance nodes? Like by looking at the shape, you can recognize now which node it is. So is it the disk or square or circle or triangles or any other thing? So to represent the chance nodes, we use circles. There is one more question I ask you about this shapes, no? Of decision nodes. So decision nodes represent squares. We represent decision nodes in squares and we represent the chance nodes in circles. You should be pretty clear about the shapes we use for the nodes, for representing the nodes. because they might be confusing sometimes, like which shape to use for which node. So this should be pretty clear. Okay. Next question. Can decision tree be used for perform clustering? Yes or no? First answer this true or false. I mean, yes or no. Can we use this or not? And then we will discuss that if it's yes, then why it is used, and if not, then why it is not used. So first of all, we'll answer yes. Decision tree can be used to perform clustering. Okay. So decision tree can also be used for clusters in the data, but clustering often generates natural clusters and is not dependent on any objective function. But in decision tree, we did not get any natural clusters. That is the drawback we get while creating this, while performing clustering using decision tree. But yes, we can do that. Temporarily, we can use decision tree to perform clustering. Next question is, what are the advantages of decision tree? So, what are the advantages of decision tree or of using decision trees? So, we can add possible scenarios accordingly. This is the first advantage we get while using. And decision tree is a supervised learning method using data mining for classification and regression method. That is what we have learned till now. Okay. It is a tree that helps us in decision making purpose. That is the first advantage. It is easier to understand. Second advantage. And it creates classification or regression both models as a tree structure. It separates a data set into smaller subsets. It is useful for large data set because it separates it into smaller subsets. And at the same time, the decision tree is steadily developed. So the final tree is a tree with the decision nodes and the leaf nodes. The decision nodes has at least two branches. At least two branches it will have. And the leaf node shows a classification or a decision because the leaf node is the final node. The tree cannot get segregated more after the leaf node. We cannot accomplish more split on leaf node. The uppermost decision node in a tree that relates to the best predictor called the root node. To select a root node is the main task while creating decision tree. Okay, so it should be the best predictor. So because on the basis of this, your whole tree structure will develop. Decision tree can deal with both categorical and numerical data. So these are the advantages of decision trees. Worst, best, and expected values can be determined for different scenarios. We can change the value of the root node and we can try with different scenarios to get the worst, best, and the expected values of the data set. Okay. Next. So now here comes the main question, that how do you choose the right node? How do you choose the right node while constructing decision tree? Because all your output, all your values depend on this only. If you don't choose the right node, your decision tree will not construct rightly. So, how do you choose the right node while constructing a decision tree? Whether we should choose some value or some node with highest entropy, we should go for that? No, we should not go for that. We should go for the attribute which is having the highest information gain. Because at the top, we want the node with we want the attribute with the highest information gain, not with the highest entropy, because highest entropy means highest impurity and we cannot continue with that. So we only go for that attribute which is having highest information gain. We select first those attributes which are having maximum information gain, and then which is having high entropy will come next at the end. Okay, so now it's clear ki how do you choose the right node while constructing a decision tree. Okay, next question. In a decision tree, the question is, first I just said to you that in a decision tree, the entropy of a node decreases as we go down as a decision tree. Is this statement correct or not? The entropy, let me write the entropy of a node decreases as we go down a decision tree. Is this statement true or not? Whether an entropy of a node decreases or not. So this statement is true. The entropy will decreases as we go down. And entropy helps us to determine the impurity of a node. And as we go down the decision tree, the entropy decreases. That is the purpose of creating the decision tree only, to reduce the entropy. Clear? The entropy decreases as we go down. Next question. What is the depth of a decision tree? What is the depth of a decision tree? Depth means how many split it will take. So what is the depth? It means a measure of how many splits a tree can make before coming to a prediction, for final prediction. How many split it will take. That is called as the depth of a decision tree, like 3 or 4 or 5, depending on the data set. So the tree depth is a measure of how many splits a tree can make before coming to a prediction. And this process will continue till when? Till further with more splitting until the tree is as pure as possible, until we remove all the entropy. Till then, this split will continue. And the problem with many repetition of this process is that this can lead to a very deep classification trees with many nodes. Because to remove complete entropy, many repetition of this process will take place. And due to that, A deep classification tree with many nodes will come up. That is why you just give the already do the pruning part. You already define that how many depth you want in your data set, 4 or 5, anything. Okay. If you don't give any max depth number already in the parameters, then it will continue till the end. Till where? Until the tree is as pure as possible, until we remove all the entropy. Till then it will continue splitting if the max depth number is not defined while creating the model. Clear? Next question. How will you counter overfitting decision tree? How will you counter overfitting decision tree? So basically, there are several approaches to avoid overfitting. That is like pre-pruning, post-pruning. Pruning have two types, pre-pruning and post-pruning. What is that? Pre-pruning means that stop growing the trees earlier, before it perfectly classifies the training set. Before only it will get stopped. But in post-pruning, it allows the tree to perfectly classify the training set and then post-prune the tree. That is the difference between pre-pruning and post-pruning. Unless both things are same. So there are multiple approaches, several approaches to avoid overfitting in building decision tree model. As I told, pre-pruning, it means it stop growing the tree earlier. Pre, as the name defined, what does pre do? Before. Just remember like this. And post pruning means it allows the tree to perfectly classify the training set till the end and then post prune the tree after classifying the training set. Okay. Clear? Pruning has two types, pre-pruning and post-pruning. Pre means before classifying, it stop, and post-pruning means after perfectly classifying the training set. Okay. Next question. Explain decision tree. Explain decision tree. So, explain decision tree means what is decision tree and what is that? So, a decision tree is a flowchart like structure, a tree like structure, a flowchart like structure, anything you can say, in which each internal node represent a test on a feature. Feature means on a column. Each leaf node represent a class label and branches represent conjunctions of features. What does that mean? Each internal node is representing a test and each leaf node representing a class label, and branches represent the features, conjunctions of features. These are the three terms: leaf node, class, and branches. And what is the main thing in decision tree? To choose correct root node. That is the main thing while doing the decision tree algorithm. Any doubt? Any doubt in this topic, guys? Anyone? I hope all the terminologies of decision trees are pretty clear to you, whether it is root node, leaf node, splitting. Splitting is, I hope you all know that splitting is the process of dividing the decision node or root node, both are the same thing, into sub nodes, yani into different nodes, multiple nodes, according to the given condition. And then finally we have the branch or the subtree, which means a tree formed by splitting the tree. So this is all the concept I have covered of decision tree in these questions. Any questions you guys have, you can ask in the comment or chat window.